So let's look at this one. So it says, what is the change in velocity of a sailboat that experiences an acceleration? Oh, okay. So think of this in terms of x comma y. Oh, let me zoom out on the screen so you guys can see it a little better. Okay. So think of this in terms of x comma y. So I've got an x and a y. So remember when we do the vectors look like this. I'm going to have my y-axis and I'm going to have my x-axis. And so when they say 5 comma negative 10, that means you kind of imagine it starting it at the origin and you go over 5 and then down to negative 10. So you kind of have this thing, you kind of have, it's not cooperating with me today. You kind of have this thing where this is our vector, okay? And the tip of the vector is at 5 comma negative 10. Well, and then that is over a time frame. So that vector represents an acceleration. All right, but also the 5 over 10 also gives us it also gives us the direction. So then remember that a change in velocity is, or actually the change in velocity, well, let me back up a second. There's a formula that's this. Right? Your final velocity is equal to your initial velocity plus the acceleration times time. And we do have a time here of 9 seconds. So t equals 9 seconds. So now, we don't know what direction the sailboat is sailing. Maybe the sailboat is sailing this way. Maybe the sailboat is sailing this way. Maybe the sailboat's going this way. But the acceleration is due to the wind, and on a sailboat, you can't really control the wind. So maybe this is the wind that's causing the sailboat to accelerate in this direction. Now, we don't know, and the question is, what is the change in velocity? So remember that our change in velocity, that's delta V, right? Well, what is delta V? Well, delta V, if you remember in your notes, is V minus V naught. Or sometimes you'll see it like this, depending on the textbook, VF minus V initial. So it's the final velocity minus the initial velocity. Well, that's easy enough to do. What I could do is I could subtract V naught from this equation, right? And I'm left with V minus V naught is equal to the acceleration times time. Well, isn't this just delta V? That's the change in velocity, is equal to the acceleration times time. But with vector mathematics, what's the acceleration? Well, I've got 5 in the x direction, right, times, very frustrating. This thing is super duper sensitive. All right, let's try this again. Times the time. Well, what's the time? 9 seconds. Right? So then my change in velocity is going to be this times 9 and this times 9. So my change in velocity is going to be 45 meters per second in the x direction, and then negative 90 meters per second in the y direction. So that's your final answer. Is that one of the options? Okay. So that's a tough one. And we never really broke down exactly how you do the vectors. Now, if we were to do this, this one's hard because you would have to have the sailboat to figure that out. Like, you'd have to have the vector of the sailboat to do it with the triangle method. Okay, does anybody have any questions on that? Does that make sense? So it's actually easier than you thought.